Hi and welcome. My name is Kevin, CTO of EVBN, founder and core developer at Matalabs, and the repo master for this project. Today, we're going to dive deep into core concepts of EVBN and get you started with some practical examples.
The EVBN is a solution that allows us to have our own customizable virtual blockchain using an existing blockchain without recurring cost, allowing us to make improvements in process, speed, and performance with very little effort. EVBN uses smart contracts to create a virtual blockchain on top of an existing one. This gives a unique state and custom functions while inherit the host chain security and connections. Our contract acts like a virtual RPC, allowing for direct permission-based transactions controlled by your EVBN's configurations. All right, that's a high-level overview. Let's get hands-on. So I'm gonna walk you through the essential resources.
Let's start with the organization GitHub. In the repository area, you're going to find all the repos for EVBN. For example, we find the TX example template for this tutorial. You're going to find the evbn.dev repo, the playground contracts. This is not important for this tutorial, and the testnet contracts, some libraries, and research and feature. So let's start with the testnet contracts. Repo contains all the testnet contracts. So let's give it a quick tour. If you go to src contracts EVVM evbn.so, you're going to find the heart of the EVBN. So you have functions like payment, that is pay. You find functions like payMultiple and functions like dispersePay. And if you go to SRC again, contracts, name service.sol, you're gonna find all the domains and identities for EVBN. And if you go to staking.sol, you're going to find all the staking mechanisms for EVBN, including the estimator. And if you go to script, you're going to find all the scripting for deploying your own EVBN. And if you go to makefile, you're going to find the easy way to deploy your EVBN. And if you go to more easy way, you can activate the EVBN init sh. And if you go to the introduction, you're going to find all the explanation that EVBN creates virtual blockchains on top of the host like Ethereum and Arbitrum with features like gasless comms and vertical scalability. And the quick start part guides you to how to deploy your own EVBN. This is for advanced users. So if you are a beginner, it's just a quick summary about this part. And everything EVBN related, you can find it again on evbn.info. On evbn.dev, you're going to find all the tools and hand utilities for the EVBN. So you get a faucet for drip tokens, a balance to check the holdings, and you're going to find the payment signatures, the staking signatures, and name service signatures. For this workshop, to keep things simple, we're going to use the pre-deploy EVBN on Sepolia testnet. So this is the address for the deploying EVBN, and if you can see, the contract code is on-chain, verified, and completely transparent. Okay, so in this workshop, we're going to cover three key things to get you transaction to the EVBN. So the first, we're going to make a basic payment function. The second, we're going to use asynchronous nonce for security replay protected operations. And third, we're gonna use an executor for advanced transaction. So this front end, this example front end, you can find it too on evbn.org in the repo in the TX example template. So if you head over to the documentation in the process of the transaction and you see the genetic flow of the transaction, a user prepared the input values from the front end or any application, design the transaction and send the transaction directly to the phishing spot to a fisher, get the transaction, check the transaction, drop it if the transaction is invalid, and execute the transaction inside the EVBN or any service. So imagine this part, it is the phishing spot, and if you click the execute, it's like a fisher execute the transaction directly. So you head over to execute that transaction. And you head over to the block explorer, you're gonna find that you successfully execute that payment with all the inputs and signature. So the next step, we're gonna apply the nonce. So quick rundown about the nonce types. In EVBN, we have two types of nonce mechanisms, sync and asynchronous execution. So if you head over to evbn.info/docs/evbn/nonce types, you're gonna find a quick description about sync nonce. So the sync nonce is a consecutive counter that increments sequentially by one each time a payment transaction is executed. And the async nonce is a non-consecutive number that is user-generated and transaction-specific. Unlike the sync nonce, async nonces do not follow that predetermined sequence and can be valid number chosen by the user. So, for every nonce, we have advantage and disadvantage regarding the syncs and async nonces. So, this time we're gonna use asynchronous nonces to execute that payment. So same, we're gonna add this token address to this address. We're gonna put this amount and we're gonna put 0 priority fee and we're gonna choose a random nonces. So if you create that signature, the main difference is that this flag is true with the non-synchronous. So you send the transaction and go to show data, you're gonna find that priority flag is true. That's because we use the asynchronous nonces. So we're gonna execute that. And if you head over to the Etherscan block explorer and use the decoded input data, you find that the priority flag is true in this time and it's the same with the async nonces we apply. So what happened if I change like the amount and sign with the same async nonce and execute it too? This time we find a little revert, invalid async nonce. So in the last transaction, we use the same async nonces. So if you make again another transaction with the same async nonce, the transaction automatically fails. Okay, we had covered the simple explanation, the explanation with nonces, and this time we're gonna explain how executors works inside the EVBM. So, an executor is an address that can only execute that transaction. Imagine as a voucher. So, if you have a voucher with your name, only you can redeem that voucher. But if someone tries to redeem that voucher with your name, obviously they can redeem this voucher. This time we go directly to say yes to are you using an executor, and I'm gonna put my address in this input. So we create a signature. You can see the new difference that this address is the executor. I'm gonna assign this and show data. So you see, this is my address and this is a part of the executor. So if I execute this transaction by myself, the same address as the executor, and you can see it successfully execute that payment. And if you can see in the input, same address as I have with the executor. So what happened if I put different address and directly try to execute by myself? Okay, so we're gonna use the name service just as an example, obviously with different asynchronous nonce. Let's create that signature, sign that signature, and show data. You can see different executor, and we're gonna execute this transaction. Okay, we had an error. Sender is not the executor. And if you can see the from, we're gonna copy this address and we're gonna decode the input data and press Ctrl F, try to paste that address. You can see the address, the from address is different to the executor. So reverse the transaction, because if you see the documentation, over the page function, in this part of the workflow, the second part, execution validation, if executor is not the address 0, check if that sender matched with the executor address. Reverse with sender is not the executor if don't match. So obviously, we try to execute with a different address to the executor, so automatically reverts.